Hello students, I am Dr. Aisha Siddiqa, Assistant Professor, Department of Chemistry, Government First Grade College, Tumkur. The second chapter prescribed for the first year BSc students is Atomic Structure. The second session in this is this particular video. In this video, you are going to learn about the dual behavior of matter and radiation, as well as we are going to derive the de Broglie's relationship. Let us have a recap of the previous knowledge. In the last video, we studied about hydrogen atom spectrum and we were able to explain the hydrogen atom spectrum based on Bohr's theory, and we also got to know that it has got certain limitations where it violates the Heisenberg's uncertainty principle. Now, what were the developments that led to the quantum mechanical model of atom? In the previous model, that is the Bohr's model, it was based on two factors. That Bohr considered that the atom has got a positive mass in the center of the atom and the electrons which are negatively charged revolve around the nucleus in certain orbits. But he was not able to explain certain things, like he was not able to explain the fine structure, and his model was not able to apply to the multi-electron system, as well as he could not explain the fine spectrum, that is Zeeman effect and the Stark effect. To overcome these limitations, Bohr's models of atom, a new model was based on two different concepts. The first one is the Broglie's concept of dual nature of matter and Heisenberg's uncertainty principle. The model is known as quantum or wave mechanical model of atom. So in the year 1923, French physicist Louis de Broglie, he put forward a theory wherein he considered that matter is not only made up of discrete particles such as atoms and molecules, it may also behave like a wave under proper conditions. So initially it was thought that the matter is made up of photons. Like photons, all the material particles will also have the dual character. You can have a look here. These are the particles which are present, like photons. So which are present here, and they also can behave like waves. So hence these are known as matter waves or de Broglie waves. He gave a relationship which is known as de Broglie's relationship, which is associating the wavelength with momentum or mass and velocity. So we have lambda is equal to h by mv, or lambda is equal to h by p, where lambda is the wavelength, h is Planck's constant, p is the momentum, m is the mass of the particle, and v is the velocity of the particle. Let us go through the derivation. This is important for your examination also. So for this, he considered a magnitude of the wavelength, magnitude of the wavelength, which is associated with the mass, which is having a mass of m, a moving body. A moving body was considered having the mass of m and certain velocity v. According to Planck's theory, the energy of this particle, the photon, is given by h nu, where h is Planck's constant and nu is the frequency of radiation. According to Einstein's mass-energy relationship, we also have energy E, which is equal to mc square, where m is the mass and c is the velocity of radiation. De Broglie later on equated these two equations, wherein mc square is equal to h nu, and nu can be replaced by c by lambda. So by cancelling out these two c's, we get mc is equal to h by lambda. M is the mass, v is the velocity, which can be written as momentum p. So momentum is equal to h by wavelength. Therefore p is equal to h by lambda. And we can say that the momentum is inversely proportional to the wavelength. In this equation, we can see that momentum, which is the property of a particle, has been associated or has been related to lambda, which is the character of a matter. So this equation gives a relationship between a particle character as well as the wave character of matter. In the next video, we'll learn about Heisenberg's uncertainty principle. These are the reference books. Thank you.